Okay, we've finished the basics of the structure and oxygen saturation curve for myoglobin, and we're ready to move on to a more challenging situation with hemoglobin. But let's take a moment and back up and remember that we're interested in these proteins for their function in the circulatory system. Let's say it again. Oxygen is going to come in to the lungs and it's going to hop onto hemoglobin there in the alveolar spaces and capillaries. The oxygen is going to hitch a ride with hemoglobin in the arteries until it gets to muscles and tissues where it's needed, and then it's going to hop from hemoglobin to myoglobin. The whole goal that we're interested in here is to understand how is it that hemoglobin can give up oxygen and myoglobin can grab it. In other words, we've kind of got the situation rigged where myoglobin grabs it from hemoglobin. Myoglobin wins if it's a tug of war over that oxygen in the muscles. So we said oxygen is going to bind tightly to myoglobin all the time. That's one thing we can do. But hemoglobin, we have a much more difficult challenge. First of all, we have to say that hemoglobin is going to have different functions in different parts of the body. Hemoglobin needs to bind oxygen tightly in the lungs. We need to soak as much oxygen out of the air we breathe in as we can, but it's going to bind oxygen weakly in the muscles or tissues. Now, making a protein that binds something tightly or weakly all the time is not a big deal. But how do you make a protein that binds an oxygen tightly under certain circumstances and weakly at other times? Much more challenging. And, myoglobin had an easy, simple function, and it had a simple structure. Hemoglobin has a complex structure and a complex function. So let's go to a couple of pages ahead and let's point out roughly that myoglobin has a spherical shape. We said it's more egg-shaped, but that's okay. And we said that there's a heme if we're looking edge on there. And we said that that has an iron in it that can bind a single oxygen. Myoglobin is a monomer. Hemoglobin, on the other hand, we said earlier in a previous chapter, is a heterotetramer. 4 subunits, and they're not all the same. Now, each of these 4 subunits, and remember we said it was an alpha 2, beta 2, there's 2 alpha subunits and 2 beta subunits. The key is that they all have a heme and they all have an iron. So, unlike myoglobin, in which you have one protein that can bind one oxygen, hemoglobin has one protein that can bind 4 oxygens because it has 4 irons. And let's understand that that's going to be seen in this situation down here. This is still reversible, by the way. Hemoglobin plus 1 oxygen becomes a complex of hemoglobin oxygen. That gains another reversibly, and we end up with 2 oxygen, and then we gain a third, and then we gain a fourth. And all of these are reversible reactions. Think of this like a bus or a taxi cab. It can carry no passengers and be empty. It can carry 1 passenger or 2 passengers or 3 passengers and 4 passengers. Hemoglobin is limited. It only has 4 spots for oxygen to sit, just like a taxi cab might only be able to handle 4 people as passengers. So what we have here is different structures and different functions, and what we see also is a much more complex situation with hemoglobin. One last thing before we leave this video, we can see the hemoglobin tetrahedron has a unique shape. Sometimes we think of it almost like a diamond or a square like this, but the way I've drawn it here, you could also think of it as if it's three cannonballs stacked on the ground and another cannonball on top of it. That's actually a tetrahedron. And when we think of it that way, just imagine what those cannonballs would be like if that's what they were. There would be a space in the interior, and that space is empty. It's not nonpolar because it's not the center of a tertiary structure. It's the center of a quaternary structure, and that's basically empty space there. That is empty, and water can go in there and other things can go in there. I wanted to mention that now because that's going to show up later in this chapter. That space is there for a reason, and we're going to see how it plays a functional role later on.